Hello everyone, welcome to Learn Overflow. In this video, we'll look into another LeetCode problem that is a jump game 6. So this is a medium level problem. We will go through the question and then try to understand what the question is asking us to do and how exactly we can do that question in a better way. We'll understand the thought process behind solving a question like this. We'll look into the examples and ultimately we'll write some code to solve this question. Okay, so let's start this video. It says like you are given a zero index integer uh, that is called nums and an integer k. So you have a nums array and an integer k. So those are the two things you have over here. Further, like you are initially standing at index 0, fine, and in one move you can jump at most k step. So when it says at most k step, that means you can jump either one step or any number of steps up to k steps. Look at like two steps, step up to k steps. Okay, so it says that you can jump at most k steps forward without going outside the boundary of the array. So you cannot go outside the boundary of the array. So you should remain in it, and by it also says that you should go forward. You cannot go backward from it. Okay. What else? It says like that is you can jump from index I to any index in the range of I plus one till either n minus one or I plus k, whichever is the minimum. You can jump in that, inclusive of both, like inclusive of the range. Okay, so we'll understand clearly all this what they're saying, and then further it says you want to reach the last index of the array being index n minus one. So target is to reach n minus one index. Okay, that's the target. It says like your score is the sum of all nums of j. So whatever with a value at particular position in the nums array, whatever we are jumping, so all the values sum will be our total score. Okay, so that will be our score. Like j being the visited, like index visited in there. Okay, so our target is to maximize the score. Okay, our target is first to maximize our score. Now let's see, whenever we find something like maximum or minimum, the first thing we should think of is whether this is a greedy problem or not, whether we can be greedy in terms of achieving our goal or not. Let's try to see an example we have over here, that is see, if we go for greedy, then we the biggest problem we may face is like we will first sort the array or kind of sort it with like all the biggest number at one place, and then we'll try to find out which are the maximum values we have, and thus we will try to take all those scores. But is it a case like see, like there are continuous, like case 2 in this case. Let's understand this example 1 1. The first is 1, then minus 1, minus 2, 4, minus 7, 3. If we have a greedy kind of approach, then what would have been date? Like it would be minus 1, then minus 2, then minus 7, like no, starting with minus 7, minus 1, minus 2, 1, 4, 3. So we'll end up taking all the bigger number like 1, 4, 3, and we'll skip on the lesser numbers that are taking our total score to be less. So with that approach, can we find like we can reach a maximum score, but are we actually able to follow all the guidelines of given over here? No, because we are not sure whether we are taking k steps actually or not. If there are continuously negative numbers in our array, then our after k steps or at most k step, our total score will go down, right? But we are not sure whether our score is going down or going up if we take a greedy approach over here. So when you cannot take a greedy approach, next think of an approach that is the dynamic programming approach. Okay, let's understand this example, and then I will explain how this approach will be helpful for us. It says like these are the elements given to us. K is 2, so the final output is 7. How they are saying, like you can choose jump from the sequence, like first you are here at 1 and you need to reach 3, right? So that's the target element at that you need to reach n minus 1, and you are at the index 0. So this is the starting index and you need to reach over here, right? So these two are given for us. So in that, they are saying like first jump to minus 1, then jump to 4, and then jump to 3. So the sum over here is 7. Okay, a very good example. Now let's try to actually see how a particular case can be done. Okay, how exactly we can visualize this question. Let's I will go ahead with example 2 over here. Okay. Now let's try to see how actually we can find a solution to this. So here we have our exact nums array. Now we are sure that we need to reach at position n minus 1, right? And we are starting from position 0, at index 0, okay? Now, if we are sure that we need to reach at position n minus 1, that means our total score, like the sum of all the score we are getting, our total score of the value, like the ultimate answer, will have 3, right? So it will be like 3, the value at this position must be added to our total score, right? That would be the case for us. So anyways, we cannot skip 3. Like I'm starting from the end, like we need to reach 3, so we must get a value 3 over here. Okay, now let's understand towards the back. We now we are at position like at this position. Okay, what can happen from 0? How many steps we can take? We can go to like we can directly go to 3, or are there any kind of steps can we take? Like we cannot go more than 3 jumps, like we cannot skip 3 positions. But from 0 we cannot go not even 3, we can go only 1 position jump, right? So like from 0, if we're at 0, we can go only till the next position, and that is the end. So if we take 0, like if we land on 0, then what can be our steps? Our steps count can be like the total score will become like only 3 plus like 0 plus 3. So that's the count over here. Okay, now say we are at next we move back and we are at 4. Okay, so if we are at 4, we can go to our 0, fine, or we can go to our 3. Like this in case 3, we can skip 0 and we can directly go to our 3. Like, so if we can if we like from 4, if we go to 0, then what will be our score? Our score will be 4 plus 0, like 4 plus 3, like score at 0 is 3, so 4 plus 3 is we find 7. Okay, and if we directly go from 4 to 3, we find it 7 anyways, right? So we find it that either way we take, we have only 2 ways over here, and either way we take, we find that the answer remains 7 for us, like 7 for us. So from 4, we know that is our total score forward 4 will be 7, right? Now we are at minus 2, fine. We are at minus 2. If we take a single step, okay, say we take a single step that is to 4, okay. So what becomes our value? So 4, from 4 we get a value of 7. So 7 minus 2, that is we will get say 5 being our score. If we put a step to 4, okay. From 2, if we take a step to 0, so we know from 0 we have a score of 3. So 2, like 3 minus 2 will be our 1, fine. And from 2, if we directly take a step to 3, our value again becomes 1, right? So we'll see what is our minimum, like maximum score from minus 2. Like if we have to step on minus 2, then what is our maximum score for minus 2? The maximum score being, we find that 5 being the maximum, so we write it as 5, fine. So that's the value we have over here. Now move back, we are moving back to minus 5. Say we are over here, and from minus 5, we find that if we take one step from minus 5, we can land into like minus 2. So if one step from minus 2, like we say minus 5 plus 5, that is 0. We got one step. And then again, if we take 2 steps, like skip 1 and to take 2 steps to reach minus 4, like reach 4, then what being our total score? There is minus 5 plus 7 being 2, fine. And see, like minus 5, from minus 5, we can take another step that is directly take to 3. So that's our k equals 3. So that's the 3 steps that we're taking. So we directly reach to 0. And so minus 5 plus 3 becomes minus 2, right? So what being the maximum score we can get if we land on minus 5? So maximum score we get is 2 itself, being 2 over here is the maximum. So we get a maximum score of 2, fine. Now we are over at this position, initial position over here, okay. So it's we are sure that we will start from here. Now what can be our steps again? Our steps, if you look carefully, our steps will be we can jump from 10 to -5, right? So if we jump from 10 to -5, our score will be 10 plus 2, that is 12. Okay, yes. So that will be 12. Then if we jump to directly to this position, this -2 position, then what will be our score? 10 plus 5, that is we find a score of 15. Fine. And what else we can jump from here? We can jump directly from 10 till this 4, because those are the spaces we can, like k equal to 3, we can jump at most 3 elements, right? So we jump till 4. And what is the output we find over here? We find that 10 plus like this 7 being the score from here. So 10 plus 7 is 17, right? So when you find all the values over here, what can be our answer at this, like total score from 10? We find that the maximum score is 17, right? So we find the maximum score 17. And ultimately, what being our answer? Our answer says it's 17. So we found our answer. Okay, so this is an approach that I took from the right hand side. So if we go ahead with the left hand side, even if we go ahead to the left hand side, that will be even the same thing. If we go ahead to the left hand side, it will be like 10 being the first value. Okay. And then at this -5, we will go 10 minus 5 will be 5. Okay. Or we cannot go back, like from -2 will be 10 minus 2, or this minus like 5 minus 2, or 10 minus 2. That would be 8 being the maximum score. Then we will come across 4. 4 will be 4 minus like 8 minus 4 will be 4, or 5 minus 4 will be 1, or 10 minus 4 or 10 plus 4 will be sorry, not minus, what I was saying, 8 plus 4 will be 12, then 5 plus 4 will be 9, and 10 plus 4 will be 14. So we find the maximum score over here is 14, and then we'll again at 0 we can look back and we'll find like 0 plus 4 is giving me the maximum, that is 14 again, and then from 3 it will be maximum will be 17. So ultimately, if we go from left hand side or we go from right hand side, however we go, we will find out a same answer. Okay, so it's the same thing we're doing, but look carefully. This is a naive way you actually found out a DP solution to this. Okay, or either DP you can say, or you can actually not a DP, you can actually keep updating the values in the nums, and based on the value in the nums array, you can actually keep a track of the final answer. The nums n minus 1 if you return, so that would be our final answer. Okay, but think carefully, isn't it something like we are doing the same task repetitively? Can we optimize our code? What I mean exactly is, say we have like we are checking for all the elements. Say for 4, when you are at 4, we are checking for all the k, like at this position I, we are checking all the I minus k elements, right? All these elements from 4. And when you're at 0, we are checking all these elements from 0. When we're at 3, we are checking all these elements at 3. Like, isn't it we have a loop, like going through the loop of nums array. And within that, we are again going through like another loop of the k number of elements for each element. So it's like we are traversing a like order of n nums array. Okay, and with order of n, on each of the index or n value, or each of the value at n, we keep on doing a k step, or the k being the complexity. I mean, like we keep on checking k elements at each position, right? So is it something we can optimize it here? Because we are checking for k again and again and again. So is it something we can have a notation that, okay, if we are finding this is the max value till now, the max value till now is like max value for the last 3 elements is some value, and we need to keep a track of that value. Okay, so we can do that. Like, can we, like, more or less we are trying to reduce this k, because if k becomes something like 10 to the power 5, that's what k being given to us as a constraint. Think of the complexity we need to go ahead with. Think of the exact values that we need to go ahead with, right? Because if that is 10 to the power 5, then we need to keep checking for all the elements actually to find out, okay, where is our key, like how much is the value we're getting. Fine. Now, how can we reduce this, like each of the fine? See, this is more or less kind of a sliding window. You are sliding a window, like these are the windows I say. These are the windows. You keep on sliding the window based on whatever position you are at. Okay, so that's a kind of a sliding window problem you can think of in this way. Now, to reduce the complexity of like this kind of window we have over here, okay, like this kind of window we find, How can we do that? We can keep a track using a priority queue. I mean a max heap. Find a max heap whenever the for the last three elements you find the max heap and you keep on tracking the elements based on that. That will be a very good way to do that, because you keep on keep a proper track on your elements. You directly find the maximum value and you add and remove. So from that, the k will reduce to a value of log of k. Like adding and removing values in a max heap or a priority queue is log of k. So that is, you can reduce from n to n, like nk to n of n log k. Fine. Can we think of anything further? Anything further is like we can have not a priority queue, but we can also go into the tree map, like a tree map that will store all the mapping for the last three elements each. Okay, that will also be, if you remember that you are going to tree map, and that will also end up having a log of k value. Also, there can be another approach to reduce this log of k, is like if you use a decreasing dequeue. Like you use a dequeue where you will store the indexes being the maximum values we have. Okay, so we'll store the indices of this nums element, and the elements will be in decreasing order. So we'll store the indices, and that will be in decreasing order. At the front of the like a front of the dequeue will have like a max value over here. Okay, and at the end we'll find the min value. Fine. Like after it will have a length of say k. Uh, k being its length or like that. And how it like when adding a new number, say num I, we'll eliminate the elements which is less than or equal to num I. Okay, and which we'll never choose in the future. Like if we have a greater value we are adding, so all the values, like whenever adding 14 over here, so all the values less than this have no point over here, right? If we have a point like 10 being already there in the Dequeue. So what's the point of adding 5, 8, and 8 and something, like, right? So once we are like, it won't be any value. Once we get at this position, the maximum value we have is 10, and we'll work with it. Fine. And after like at this position, once we are here, like what's the value of like 10 being not there at that time? Okay. Once we are pointing over here. So once we have found 14 being our largest value till now, so there's no point keeping a track of 5 and 8, right? And once we have reached 17, then there's no point keeping a track of 8, right? We have 14. We only kept a maximum value being the 14, and we once we find a greater value, we'll add it and add 17 to our DQ. Okay, so that's the basic idea. So if we go ahead with something like that, then what can we do? We actually can reduce this whole k, like whole complexity of k, to an order of 1. So ultimately, we can reduce this to an order of n, like the whole question be an order of n. So once we can do something like that, our whole question of the whole time complexity will reduce by many folds. Fine. So that will be our approach over here. Now let's code this, and after that I will make you understand what exactly I was trying to say the whole time and how exactly we can do this. Okay. Now let's code it further. Okay, so here we wrote a whole question, and let's see how fast or how slow it works. So we find that this is the 40 ms solution that we came across with. So let's understand what exactly the question is trying to say and what like how we solved it. Okay, let's understand this code actually. So what we did, we just took the length being nums of length being n. Okay, after that we took a dequeue. A dequeue is, you remember, a dequeue is something where we can add at the front and also like add and remove at the front and end, like at the both ends, like a double-ended queue we have over here. Okay, so we are using, as you say, the array dequeue for that purpose, and we like this particular dequeue will help us in like storing the index of the elements. Okay, like whatever the elements we come across, it will help us to store the index. So for that purpose, we actually took the dequeue. Like I'll explain further in the code how it is working, but we'll keep a track that all the like the elements the front will be something like the maximum element pointing to max values, and the elements and the towards the last is the minimum element. The whole dequeue will be in a decreasing order. Okay, that's our idea behind the whole dequeue. Now let's understand. So we just initially offered zero being the first index of the array. So we just offered zero. Now we started our position something like this, like a loop, a single loop. You can find that's a order of n, as I say. So single loop, and in that we were finding like we're starting from 1 till n being the length. Okay, that we simply did nums of I, like at this current position, nums of I is plus equal to nums of dequeue dot peak first. Peak first is at the in the front, whatever be the elements, we are just peak to the element, and we find like till now we have only zero. So we find the dequeue nums of zero is there. So the peak first returns zero, and nums of I is one. So we just summed up the value of the elements over here. Okay, like if I just take a small example for you, example 2 I was going out with. So let's take this example and let me show you what exactly it means. So at initially you inserted zero into our particular dequeue, fine. After that at nums of I, when you were at this position, fine. What we did, we said like -5 plus nums of zero, peak first returns as zero. So -5 plus zero is returned as 5, and we added that to our particular nums of I. We are just changing the nums of I so that we are not using extra space for that. Okay. Further, we check like if dequeue, like while dequeue dot not empty, like while we can keep continuing, and we are checking the dequeue dot peak last. Peak last is what? Peak last is zero. Like till now, dequeue has only the array index zero over here. Okay. So we're saying till dequeue dot peak last is less than equal to nums of I. Now, is it less than equal to nums of I? Nums of I is currently 5, and peak last nums of peak last is 10. So is it less? No. So this loop will initially not work. Then we are adding dequeue dot offer last. We added what current value, that is 1, to our dequeue. So that is 1 being added over here. Fine. So that's the step we did, and we find that if I minus dequeue dot first, I is 1 minus dequeue dot first is 0. Like currently 0 is there. So dequeue dot first is greater than equal to k. We simply poll the first element. So once we have our like the k being the length of the window we are looking for, once we are done with our maximum window, then we remove the value over here. Like we remove the initial, like the farthermost values we have got, and we're removing that. So that's what the idea over here. So what we did basically, we keep on adding the indices till the indices we find that it is if our nums of I, that is nums of peak last, that is the last element we inserted, is less than nums of I. Fine. If it is less than nums of I, we'll remove the last element. We'll just keep a track of all the bigger element we have in our the whole array. Okay. So that's the idea behind the whole dequeue. And you as you saw, like it actually worked for us in a 40 millisecond solution. If you think there can be further upgradation or further modification in the solution, if you think that can actually help in reducing the time complexity, I'd love to know your thoughts in the comments as well. So, but till then, this is the whole concept behind this question, and this is how you can actually solve it on in a very fast solution. So I hope I can make you understand how this solution works and what you need to do to solve it. So thank you all for watching this video. Also make sure to comment down on any kind of thoughts you have, or make sure to like the video, so that gives a motivation to me as always. Also, if you haven't subscribed to this channel already, make sure to subscribe that also. You will get regular LeetCode videos on daily problems. Thank you all for watching this video. Hope to see you soon in my next video.